problems we're working on tonight are combinations which are different than permutations because the order does not matter. And then in class, we either did it today or we'll do it tomorrow. I can't remember how I have it set up, but at some point we'll practice with a scavenger hunt where you have to determine whether it's a permutation or a combination before you can solve the problem. This problem number 7 says how many triangles may be formed by selecting 3 of 7 points on a circle as the vertices. So let me label 7 points on this circle: A, B, C, D. I could have spaced them better. E. That's 1, 2, 3, 4, 5. F and G. If I make a triangle with these 3 points as the vertices, that's triangle A, F, C, or I could call it triangle A, C, F, or I could call it triangle C, F, A, or triangle C, A, F, or triangle F, C, A, or triangle F, A, C. There's 6 ways to name that triangle, but no matter how I name it, it's still the same triangle. That's why the order doesn't matter. It doesn't matter which order I put these vertices in. It's still the same triangle. So we worked on some problems to understand this formula, but the formula for combinations is the combination of n items taken r at a time is equal to n factorial over the difference between n and r factorial, just like the permutations formula, but then we're also dividing by r factorial. So try to figure out what n is and what r is and substitute them into this formula during the pause and see if you can figure out how many different triangles can be made, and come back after the pause and compare your work to mine.
Paused.
We're making a triangle from 7 points on the circle, taken 3 at a time, because if it's a triangle we need 3 points to make the 3 vertices. So n is 7 and r is 3. So that would be 7 factorial over 7 minus 3 factorial multiplied by 3 factorial. The 7 minus 3 factorial is 4 factorial. And if I expand the 7 factorial, it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. But 4 times 3 times 2 times 1 is 4 factorial. So I'm just going to leave that and cancel the other 4 factorial in the denominator. This product is the same as that product. So I'm left with 7 times 6 times 5 over 3 factorial. Well, 3 factorial is 3 times 2 times 1, which is 6. So we have 7 times 6 times 5 divided by 6. But before I go further with that, I want you to see why we're dividing by 6. Remember in the beginning where we said we could that single triangle could be named 6 different ways? This is why we're dividing by 6. I do have 7 choices for the first vertex and 6 choices for the second vertex and 5 choices for the third vertex. But whichever those 3 vertices are that I choose, I would have to divide by 6 because there's 6 different ways to arrange them that would mean the same triangle. So the 6 cancels out and we get 7 times 5, which is 35 triangles. Okay, I hope that helped with that.